Is my screen visible?
Yes, sir.
Yes, sir.
Okay. So, in the last class, we studied about aerodynamic drag. Another component that affects the aerodynamic of vehicles is aerodynamic lift. It's same as drag, but here the lift happens by overturning the vehicle. So I'll show you an example. Okay, this is a drag race, and you will notice the vehicle moving upwards. This is partially due to lift and also created by the driver itself, but this is how the lift happens. Okay, so this is how it happens. If you view the video, so this is the example of a lift. Okay, so that is how a lift happens, but that is intentionally done by the driver itself. But a lift happens in such a way. Okay, so lift is the upward thrust that is provided on the vehicle. So lift in the case of an aeroplane is an advantage. So that is how the lift happens. What is happening is in an aeroplane, this is an aerofoil that is shown here. That is the wings of the aeroplane. So in the aeroplane, you can see here there is a lower streamline and an upper streamline. Okay, upper streamline of the air is moving towards the upper side of the wing, while the lower stream moves underneath the wing. Okay, this is how it goes. So the shorter distance, you can see here, the shorter distance is underneath the wing, while this is a longer distance. So the air has to travel from here to here, and it is a longer distance when compared with the lower stream that is shown here. So initially the pressure will be uh, the pressure will be higher over this point rather than this point. Okay, there is a small difference here. The velocity will be high here rather than here. Okay, uh, due to the longer distance it has to travel and due to the pressure. So in case of pressure, you all have watered plants using garden hose, right? So how do you water the plants? If you have to give it to a longer distance, you have to provide if you have to make higher pressure, right? You have to make higher pressure by reducing the cross-sectional area of the garden hose. So depending on that, the velocity increases. The same phenomenon happens here. At the higher pressure region, there will be higher velocity, while in the case of a lower pressure region, there will be low velocity. Okay, and due to that, the high pressure always tries to move to the lower region, from the high pressure area to the lower pressure region. So due to that, there will be a lift happening. Okay, a lift will be occurring inside the or at the aerofoil of the plane. That is how a plane lifts up. So the lifting up is shown here. This is how it lifts up. Okay, this is ideal only for an aeroplane. So this is called a positive lift. So it will be lifting, and hence it is known as positive lift. So this is applicable for an aeroplane. But when coming into the vehicles, you can see here, this is how the air travels in a vehicle. So this is, we know that there will be drag occurring here and there will be a drag occurring here, that is called the base drag. This is the normal aerodynamic drag, while this is the base drag. So that is the drag occurring. Lift occurs in the same way as that of an aeroplane, but it is slightly different. We need the negative lift here. So you can see here, the air has to travel from this portion to this portion, and which is the longer distance. So it has to go like this, and then like this to the rear of the vehicle. While underneath, it is having a shorter distance. And due to the lower, so you can see here, the cross-sectional area is much lesser here when compared to here. So obviously, the velocity here will be much greater than this portion. Okay, obviously the velocity will be higher here than compared to here. So the pressure will be greater at the bottom of the car rather than at the top of the car. And due to that, the high pressure always tends to move to a region of lower pressure, and this in turn provides a lift on the car. Okay, that is how the aerodynamic lift occurs. So this is undesirable in a car. So once it flips over, it is very hard to bring it back in the downward position, and also we will lose maneuverability of the vehicle. So for that purpose, we have to reduce the vehicle lift that is occurring in the car. So how do we attain the negative lift? Okay, we need negative lift. We have to provide the car has to be stayed on contact with the ground rather than lifting up, and that is the desirable condition. So if it is lifting up, it is called positive lift, while if it is staying on the ground, it is known as negative lift. So for that purpose, we are providing aerodynamic design. So you can see here, this is a rather simple design of a car, while here you can see it is more proficiently in the aerodynamic shape. So the air can travel here much faster when compared to here. Okay, that is how we are reducing it. We are uh, reducing the velocity that is traveling underneath the car when compared with the top of the car. So the velocity, once you increase the velocity that is occurring here, okay, once you are increasing the velocity here, obviously a region of higher pressure will be occurring at this position rather than this position. That is how you are attaining the vehicle lift. But the vehicle lift at the center portion of the vehicle, so you can see here that the green area that is shown, that is always occurring at vehicle lift. There will be no possibility of making a negative lift here. There is no possibility of making a negative lift here. But while if you are achieving negative lift at this point and this point, the vehicle always stays in the ground. So that is our aim. We can't provide here while we can provide it here. So at this region, you are restricting the air to move here. So there is a lower ground clearance, and there will be another component that is present at the fender of the vehicle, and that we will be studying in later class. And due to that, the vehicle lift will be so if the velocity here is reduced, the velocity here will be greater. So hence the pressure that is generated here will be greater when compared to here, maintaining the negative lift at this point. And while it is accelerating here, the air underneath the car will be much faster because of the Venturi effect or the lower cross section. Due to the lower cross section, air tends to move at a higher speed. Okay, and due to that, there will be a high pressure here while low pressure here. Hence, there will be lift at these two positions. And when coming here, you can notice there is a tilt here, right? And due to this tilt, there is a larger cross-section area when compared to this point. So due to this larger cross-section area, the pressure generated here will be low, while the pressure here will be greater, because here there is a turbulent flow, and finally the turbulent will be here there will be a vacuum creating. So due to this turbulence and the higher pressure here when compared to here, it will obviously provide a downward force, thereby maintaining the vehicle on the road. In some designs, at this point also we will obtain uh, positive lift. At this point also we will obtain positive lift, and even if you are obtaining positive lift here, it does not matter, because due to this upward motion, still this portion of the vehicle tends to move downwards. Only if this becomes positive lift, the vehicle overturns. At the front of the vehicle, if it is always in the negative lift position, then you don't have to worry about the lifting up of the vehicle due to the engine weight concentrated at the front of the vehicle. So the weight is concentrated at the front. So if you have a negative lift at the front, that is enough. And additionally, a positive lift at the rear helps in maintaining the weight to be at the front of the vehicle, thereby reducing the lift of the vehicle. So that is how aerodynamic lift occurs. Okay, so that is how lift of the vehicle occurs. So next is the lift coefficient. So same as that of a drag coefficient, which we have termed as CD, lift coefficient is termed as CL, and it is the measure of variation in pressure created above and below a vehicle's body. So it is a pressure created. So I had told you there will be a lower pressure here and a higher pressure here, and due to that a negative lift is formed. And in normal conditions there is a higher pressure here when compared to here, and hence there will be a positive lift. Okay, so that is the it is a measure of this pressure difference and how the lift occurs. Okay, so obviously the lift coefficient value must be lower to reduce the lifting up of vehicle. So you can see here the positive lift reduces the tire to ground gap. So if there is a positive lift, always the vehicle upturns or it lifts up. So that will be reducing the stability of the vehicle. While in the case of a negative lift, it increases the tire rod holding. So it is holded or grounded to the ground or the road, and hence it will never lift up, which is desirable. So we need negative lift. So that is how lift occurs. So one of the factor that affects lift and drag is the underbody floor height. So what is underbody floor height? Underbody floor height is nothing but what we term as ground clearance. It is the distance of the road or the ground surface, the distance between the ground surface and the chassis of the vehicle. So this is the chassis point of the vehicle. Rather than tires, it is a chassis. So that is how the ground clearance is termed as. So you can see there are two types of ground clearance here. One is a large ground clearance and other is the small ground clearance. So when looking at this figure, you can see that large ground clearance provides negative lift much better than that of a small ground clearance. Okay, so what is the reason for this? This is nothing but, I have already told you, when you are reducing the cross-sectional area. So once the area between the chassis of the vehicle and the ground surface reduces, the velocity increases, and due to this velocity increase there will be higher pressure generated here. Okay, and due to the higher pressure there will be a low pressure region that is created here, and hence there will be a positive lift occurring at a small ground clearance vehicle. While in the case of a large ground clearance vehicle, you can see that the velocity is much lesser when compared to here, and the pressure here will be higher rather than underneath the car, and it produces negative lift. So that is how the underbody floor height depends on the uh, aerodynamic lift of the vehicle. So you can see here, these are all the car aerodynamics that is formed. So basically there are two types of aerodynamic features. One is the drag and other one is the lift. So the drag that occurs is at the front nose end of the car. This is called the nose end of the car, and the rear part, and this drag is known as base drag, while this is the aerodynamic drag. Okay, and next comes the lift. So you can see the lift direction, right? So this is the lift, and the lift is facilitated by the movement of air underneath the car. Okay, this is how lift is termed as. So Okay. Next is the aerofoil lift and drag. So you can see here, we have already stated about the underbody floor height, and we have stated that larger ground clearance is better for negative lift condition. So you can see here itself, this is the lift coefficient, that is CL, that is denoted at the y-axis, and this is the h by b. You don't have to know that this is the ground clearance. Okay, this is the ground clearance that is shown here. And as ground clearance increases, so here it is 0 and here it is 1. As the ground clearance increases, you can see the CL decreases. You can see how the CL decreases. It is mostly lower at this point. Okay, but further reduction results in a slight increase in lift, a slight increase, uh, but it tends to form a constant value at this point. Okay, there will be a you can see how at the small ground clearance there will be the lift will be much greater, very big, that is about 0.3, while at here at the ground clearance it will be negative 0.3. Okay, negative 0.3, negative 0.2. At that point only the lift occurs. So this point it will be a negative lift, while this point it will be a positive lift. So this is a zero axis, this is the positive side, and this is the negative side. So this is the negative lift portion, and this is the positive lift. So until this condition there is positive lift, so this will be approximately 0.1. So once the h by b ratio or the ground clearance ratio uh, till 0.1 will be about 0. Okay, for this vehicle, for each and every vehicle there will be a difference. For this type of vehicle, when adjusting the clearance, you can obtain the lift in such a way. Okay. Okay, another component that assist with uh, the lift is a spoiler. So I assume that all of you know what is, or at least have heard about a component named spoiler. It is nothing but you can see it here. So this is the spoiler part of the vehicle. There will be a small wedge or a small shape that is provided here. Okay, so if you're comparing it with an aerofoil, so this is the shape or a size and shape of a aerofoil that is present inside an aeroplane wings. So this is how a wings inside the aeroplane is placed in an inclined direction. Okay, and specifically in this manner, it is inclined in this manner rather than the opposite manner, that is just the opposite of this. Okay, so the here the high pressure is generated here while the low pressure is here, and the high pressure always tends to move to the lower pressure, and hence lift is occurring at this inclined plate. But in the case of a car spoiler, you can see the inclination is in the opposite direction when compared with the aerofoil or that of an aeroplane. So when the air comes here, it hits this plane first and then underneath. So a region of high pressure will be always created uh, above the spoiler rather than below it. So on top of the spoiler, a higher pressure will be generated, and while at the lower portion, there will be a lower pressure region. And due to the higher pressure moving to lower pressure region, a negative lift is created at this spoiler. So this is an example of a retractable spoiler. So it is present inside a vehicle, and you can see how once it retracts, how the movement of air is occurring inside the wind tunnel. So you can see how it is moving. Okay. Next is the front end nose shape. Front end nose shape. So the front end is of the car is always known as the we have termed it as fender and all, but it is basically a nose shape. Okay, You are providing a nose shape in front of the vehicle, and various shapes are provided. And you can see each shape that is shown here. You can see a down turned. So here the nose is concentrated in the downward position. Here it is the medium or central nose, or approximately at the center of the vehicle. You can see it here, and then the upturned nose. Okay, upturned nose. There is another type of design that is shown in the nose profile. So this is also another shape. You can see here in Formula One cars and all, we are providing a nose shape in this manner. While in the case of a car, we are providing it in the this manner. So both in both the conditions, the air is going inside this fender. Okay, you can see this is a gaps. So through this, the air can move inside. In the same way, here also the air can move inside. So we know that there is an engine present inside the car, and it has to breathe in the air from the atmosphere for during the suction process. And due to that condition, air has to flow inside the bonnet of the car, and for that purpose we are opening or providing openings inside the fender or at the nose of the vehicle. So you can see here in the case of a Formula One car, and also in the normal conventional car, we are providing holes or openings inside the fender. Next, how to reduce drag. Okay, we are having two aerodynamic properties that are occurring in the car, and one is aerodynamic drag, and while other one is the aerodynamic lift. So how do you reduce the drag, or certain components that influence drag conditions and reduces drag? Okay, so first condition is profile edge rounding or chamfering. Profile edge rounding or chamfering. So what is profile edge rounding or chamfering? As you can see here, at the nose end of the car, we are providing a rounded part almost above the headlamps. Okay, the headlamps and the bonnet itself is rounded or chamfered. In it is either rounded or chamfered. We are seeing mostly rounded, but chamfered also is common because due to the bonnet hood being opened, you have to open the hood, and due to that there will be a wedge that is provided at this point. So a more chamfered method is seen usually rather than a rounded, because a pure rounded part is difficult to fit inside a vehicle. So we can see here also the this is the drag coefficient, that is the CD at the y-axis, and while this is the radius of the chamfer or the rounded edge. And you can see here itself, the chamfered provide much lesser coefficient of drag when compared with rounded. Okay, the chamfered provides much lesser uh, coefficient of drag when compared with rounded. So chamfered is most commonly used, while rounded is present in recent cars and concept cars. Rounded design is preferred due to the I have explained in the class before, a teardrop size profile. So in a teardrop profile, you know that the coefficient of drag is the most least. So hence a rounded profile is much more similar to the teardrop profile, and hence a rounded is always preferred. But when looking at the graph, you can see chamfered provides much lesser coefficient of drag when compared with rounded edge. So that is the profile rounding and chamfering. Okay, one point I missed is that in the underfloor height versus lift, you can see there are two conditions: large ground clearance and small ground clearance. But in Formula One cars, you are not providing any ground clearance. Okay, you can see here there is a component or a part that is fixed here, which we will be studying. And due to this thing or this fender that is present at the nose part of the Formula One car, no air passes underneath the car, so thereby reducing the ground clearance problem that is occurring here. Okay, that is why lift does not occur. So how we are directing the air, you can see the air being directed here. The air is then carried from here due to this shapes that are, or the aerodynamic designs that are provided. The air is carried from here through the side of the vehicle and then to the rear. So we are providing, due to the spoiler, or this is another component that is a negative lift aerofoil, which we'll be discussing. And due to this component that is present here, there will be a negative lift occurring at this point, thereby forcing the Formula One car onto the ground. So it always stays in the ground. But during cornering and all, it tends to lift up because at some point the air escapes underneath the car due to cornering. So at the cornering condition, you know that there is a weight shift occurring at one position to another, and due to that weight shift, one of the wheels, depending upon the turn, one of the wheels always lifts up a little, and due to that lifting up, there will be a small gap that is provided at the front end of the vehicle. And if the speed is much greater, due to the pressure difference, there will be a lift occurring in the Formula One cars. And if you look at videos in YouTube, you can see such accidents occurring. And these are occurring at the cornering position, when the speed is much greater at a cornering position. In a straightforward position, there is no chance of air leaking underneath the car, and due to that, always a negative thrust will be provided on the Formula One car. Okay, so that was one of the methods for reducing drag was profile edge rounding or chamfering. Next is the bonnet slope and windscreen rectangle. So there are two components here, bonnet slope and windscreen rectangle. So the bonnet of the vehicle is this part, okay. This part is known as the bonnet of the vehicle, and this is the windscreen. This is the windscreen, this is the bonnet. And what is the bonnet slope? So when we are looking at the horizontal, so if you are looking at an horizontal from the windscreen point, this is an horizontal, it is the angle between the horizontal of the windscreen to the bonnet of the vehicle. So you can see the angle that is formed here, that is shown as alpha here, and this alpha is the angle between the horizontal that is provided here and the bonnet that is of this vehicle. Each and every vehicle has a different bonnet slope, and depending upon that, there is differences. So you can see here on increasing the bonnet angle. So this is the bonnet slope angle, and this is the drag coefficient. So you can see CD is greater when the bonnet slope is 0. So when the bonnet slope is 0, you can see it has the horizontal and the bonnet slope will be equal. The horizontal and the bonnet slope will be equal. So CD at that point will be much greater, okay, than compared to bonnet slope angle at 10 degree. So it is not a huge difference. The degree of bonnet slope that is provided will be about 10 to 20 degree. 20 degrees a heavy, 20 degrees a big inclination. That much is not provided. At least to 10 degree it is provided, and this bonnet slope facilitates reducing drag coefficient. That is about bonnet slope. And what is a windscreen rake angle? So when you are looking at a vertical line, so vertical line of the windscreen, or vertical line of the windscreen is provided here, and you can see an line or the inclination that is formed by the windscreen. So the angle between this windscreen axis and the vertical axis is known as rake angle, windscreen rake angle. And here also, when you are plotting the graph for CD and windscreen rectangle, you can see from 10 degree to 80 degree it is shown here, and the CD value decreases from 0.38 to approximately to 0.32 at about almost 80 degree. At almost 80 degree, the coefficient of drag is much less. So if it is in the zero condition, in the case of an KSRTC bus and all, you can see there is no windscreen rake angle. In old KSRTC bus, there is no windscreen rake angle. So for that purpose, the aerodynamics or aerodynamic drag will be much greater than compared to a car. That is because there is no windscreen rake angle, and due to that, one of the problems for aerodynamic drag is the windscreen rake angle. So in the case of a car, we are providing it from about 10 degree to 80 degree. Okay, that is the normal conditions for coefficient of drag under bonnet slope and windscreen rake angle. So you can see here the bonnet slope that is provided. So in a sports car, you can see the bonnet slope will be much greater than that of a sedan or a saloon car that is driven conventionally. Okay, so you can see here the bonnet slope is much lesser when compared here. Okay, and in the case of windscreen rake angle, you can see this is almost there is a negligible windscreen rake angle that is provided. This is a new KSRTC bus, and hence there is a slight inclination, but still the aerodynamic drag that is produced here will be much greater. So the problem is that if drag increases, we have to exert more power from the vehicle to move in the forward direction. So we are going against the airspeed, and going against means you have to provide more power. So if you are reducing the coefficient of drag, lesser power is required to overcome the airspeed, and that is why we are providing various designs to the vehicle for improving or reducing the coefficient of drag. And this is that of a KSRTC bus. And in the case of a Lamborghini, you can see it here. It is provided a sleek angle. So you can see the bonnet slope is much lesser, much higher, and the windscreen rake angle you can see even greater, approximately 70 degree. Okay, 65 to 70 degree rake angle is provided in a Lamborghini, and you can see how the air flows here. It can move at an easier direction than that of other saloon cars. Okay, next is the roof and side panel Camry. Roof and side panel Camry. This is another design that is provided. So what is a roof and side panel Camry? So if you look at the roof of the vehicle, in the roof of the vehicle, it is not always provided a flat region. It is not an horizontal region, or it is not parallel to the ground surface. A small amount of rounding or a small amount of camber is provided at the roof. In the same way, at the side of the vehicle also, if you look at the car at your house itself, you can notice there is a small side panel camber that is also provided here. It is not completely flat, while there is a small camber that is provided here. And these both assist in reducing coefficient of drag. So you can see here, a roof camber is shown here at the x-axis, and this is the change in coefficient of drag. And you can see the drag reduces in the negative direction. So this is 0, this is minus 0.01, minus 0.02. It is a difference. Okay, that is why the minus value occurs, and due to that you can see it reduces, the coefficient of drag reduces according to the roof camber increasing. So it is increased about 0.002. Okay, sorry, 0.02 units. So only that much is the difference. It is not a huge cambering that is shown here. It is a small cambering. So it is about 0.02, 0.04, and 0.010. So you can see a huge difference or a change in drag coefficient occurs at this point, and on further increasing the camber, it again increases the coefficient of drag. That is the problem. If you are increasing it above, you can see 0.08, it always increases. Coefficient of drag increases. This is because the distance again the air has to travel will be very greater. That is the reason for increasing of coefficient of drag here. But while in the case of side paneling, it always decreases. Okay, if you are providing a side panel camber at both sides, so this is one side that is shown here. If you are giving a side panel to one side, it reduces the drag coefficient, obviously reduces and keeps on reducing on increasing the side panel camber. So that is another component. So you can take about a 10 minutes break and you can return to the class at 12:20.
Sir, apa training so?
Attendance fourth or 11th.